Hello and welcome to this math tutorial. Let's find the real value of x in these exponential equations. Alright, so we have 8 exponent x plus 2 exponent x equals 130. Alright, so we know already that we can write 8 raised to the power of x in terms of base 2 to be 2 raised to the power of 3. Then we have raised to the x plus 2 raised to the power of x equals to 130. Now, let me switch the power in this case so that we can have 2 raised to the power of x, parentheses 2 raised to the power of x, exponent 3 plus 2 raised to the power of x equals to 130. Alright, now this is where we can now represent 2 raised to the power of x with a letter. Okay, we can choose any letter from the alphabet. Alright, so we can say let y equals to 2 raised to the power of x, so that this equation will now become y exponent 3 plus y equals to 130. Now, I can write this, okay, in expanded form as that's as the sum of 125 and 5. Okay, 5 is a factor of 125. Okay, so when 125 is a cube number, then 5, we know 5 to be a factor of 125. So this will be y raised to the power of 3 plus y equals to 125. Okay, 125 minus 125 plus 5. Beg your pardon. All right, so in this case, I'm going to move everything on the right hand side to the left hand side so that we can have a cubic equation. All right, so when this is moved to the left hand side, we have y cubed minus 125 plus y minus 5 equals to 0. Now, it has to be y cubed minus 125 plus y minus 5 equals to 0 is because already I know that on the left hand side we have y cubed, and I know that 125 is a cubed number when expressed as a power of 5. So which means y cubed minus 125 plus this y, then the exponent of y is 1. So that's why this is what? Minus y minus 5, because the exponent of 5 in this case will be what? 1. All right, so now I said 125 is a what? Is a cube number. That is because we can write 125 in terms of base 5 to be 5 raised to the power of 3. So that y cubed minus 5 cubed plus y minus 5 will be equals to 0. Now, this is where we can now apply what we call difference of two cubes. Okay, that is using one of the basic algebraic identities known as difference of two cubes. Okay, difference of two cubes. For difference of two cubes, if you have a raised to the power of 3 minus b raised to the power of 3, this will be equals to the product of a minus b, okay, and a squared plus ab plus b squared. So that is exactly what I'm going to apply in this case. Okay, where we have, that's to the first part, where we have y cubed minus 5 cubed. So this will be y minus 5, okay, multiplied by y squared plus 5y, okay, plus 25. Then also we have plus y minus 5 equals to 0. Now, we can see here that y minus 5 is a factor that is common. So I'm going to factor out y minus 5. So that this will be y minus 5 multiplied by y squared plus 5y, okay, plus 25, then plus 1, which will be equals to 0. So which means we have the product of y minus 5 and y squared plus 5y plus 26 equals to 0. So we have what we call zero product identity in this case, so that we can set each of these equals to 0. So for the first one we have y equals to 0, while the other one will be y squared plus 5y plus 26 equals to 0. So if you solve for y, in this case, the value of y will be equals to 5. But we are not done yet. Okay. All right. So then also in this case, we have a quadratic equation. And looking at this quadratic equation, okay, we cannot, now, it's not possible to have two numbers which are factors of 26 that when added together will give us plus 5, okay? So, which means no factor of 26 can give us, there's no two factors of 26 that when added together will give us 5. Okay, so which means in this case we then apply quadratic formula. All right, so now this is the first value of y, okay, which is a real value. Okay, so in this other case, we're going to apply quadratic formula. Apply quadratic formula. And we know that this will be y equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. So where a will be 1, b is 5, and c is 26. So we plug in the values so that y will be equals to negative 5 plus or minus square root of 5 squared minus 4 times a. A is 1, then times 26 divided by 2 times a, which is 1. So that y will be equals to minus 5 plus or minus the square root of 25. So 4 times 6, 4 times 6 is 24. Okay, 4 times 2 is 8. This will be 104. So we divide 104 by 2. Okay, because 2 times 1 is 2. So that this will be, we can now have y equals to negative 5 plus or minus, so 125 minus, this will be 79. So we have minus 79 because 79 added to 25. Yeah, that will be 104. So divided by 2. Now, here we have a complex what? A complex root because of root minus 79. And of course, we know that root negative 1 is the same thing as what? Imaginary number. And that is iota. That will be y equals to negative 5 plus or minus. So in this case, we're going to have root negative 1 multiplied by root 79, okay, divided by 2. Okay, so that y will be equals to what? Negative 5 plus or minus, this will be I root 79 divided by 2. So this will be rejected because this is a complex, in this case, this will be rejected. Okay, it does not satisfy this equation. Okay, as far as this is concerned. Okay, now the only solution to this question, okay, is when we substitute, we put back what we represent as y and then solve for the value of x. But in this case, this will not work in this case. All right, so we now recall, so this will be rejected. So we have that y equals to 5. Okay, then this will be then y equals to 5 is the what? Is the only root. Okay, is the only root that can be used to find the value of x. So now let's recall from here. So we have recall. We know that y equals to 2 raised to the power of x. Okay, y equals to 2 raised to the power of x. So for 2 raised to the power of x, we can say 2 raised to the power of x equals to 5. Okay, so that in this case, I'm going to take log of both sides. Take log of both sides. So this will be log 2 raised to the power of x plus log 5. so that this will be x log 2 equals to log 5. So now dividing both sides by log 2 so that we can get the value of x. This will be x log 2 divided by log 2 equals to log 5 divided by log 2. Then x will be equals to log 5, okay, over log 2. Now the value of x will then be, the value of x will be log 5 to base 2. So this is the only solution to this question. Now we can also verify our answer. Okay, we can verify our answer. Now let's verify. Now let's verify. So we have 8 exponent x plus 2 exponent x equals to 130. Now we have here that x equals to log 5 to base 2. So that means this is going to be, we know that 8 can be written in terms of base 2 to be 2 raised to the power of 3. Okay, then x is what? Log 5 to base 2. Okay, then plus 2 raised to the power of log 5 to base 2. Okay, now will it be equals to 130? That's it. Okay, now in this case, this is going to be, so if you multiply the powers, we're going to have 2 raised to the power of, this will be 3 log 5 to base 2 plus 2 exponent log 5 to base 2. Okay, so I'm going to take this here because this is when we have what we call when we have what we call transposition of logarithms. So this is going to come here, so that this will be 2 raised to the power of log 5 raised to the power of 3, okay, to base 2, plus 2 raised to the power of log 5 to base 2. Okay, now 5 raised to the power of 3 is 125. 5 raised to the power of 3 is equals to 125. So we can then write 2 raised to the power of log 125 to base 2 plus 2 raised to the power of log 5 to base 2. Okay, now this is where we can now apply one of the properties of logarithms, which is when we have a base a, that's a raised to the power of log b to base a, which is equals to b. So which means when the what? When the base, okay, and the base of the exponent, okay, are the same, then we strike out this, then we have what? 125. So this will be 125 for the first one, then this will be 5. And 125 plus 5 is 130, which is why x equals to log 5 to base 2 is the only real solution that satisfies this equation. The noblest pleasure is the joy of understanding. Bye-bye.